I'm in the shop today. I am the only person in here. Today I have the opportunity to get some stuff done. So what I want to do is I want to walk you guys through the Immerse to Learn manual milling part. So there is a video on some instruction for this, but I'm going to walk you through it on the way that we would do it here. So here's our part. I've already set up a couple things for us to use. I've grabbed all my tools, set them over here on one of these mills, just to kind of aid in getting everything done. So I'm going to start by squaring this thing up, and the way I'm going to do that is I'm going to come in and just do some adjustments here. I'm going to take my end mill, and I've already got my end mill chucked up in a collet. I'm going to come up and I'm going to conventional cut up this edge, flip it around, and then I'm going to do the same thing. I'm going to come up the other side. So I'm going to come up this side as I go around it, just flip it around. I'm going to bring it to 2.5 long. So that takes care of my overall length of 2.5 inches on there. Hopefully you've already got the print with you and can kind of follow along with some of these dimensions. So I'm going to start by just squaring the part. I have already trimmed my head, squared my vise, taken care of all of my preliminary things that I need to have done. So you won't have to worry, or I won't have to worry about any of those things. But every time that you come up to the mill, you want to make sure that those things are being done. Okay. So I'm in high gear, so I'm going to be in reverse. Move my print out of the way. Make sure my quill is nice and tight. Move my table up. Come into the edge of this thing. Snug my locks down. For both my X and my Y. I'll leave my Y just a little loose so I can get across there. So on this side, all I want to do is clean up just a little bit. Just off of my saw cut. I don't have a ton of material on this thing, so I don't want to take any more than I have to off of this side. Adjustments made on that. Also, probably a little dry. It's been a few days, so it's been about a week and a half now since we run any other machines. So, alright, we've got that side squared up. So we're going to go ahead and take it, flip it around. Clean out, pull my parallels out, clean out my area so I can set this thing back down and make sure that it's square as I go. Make sure I'm free of any chips. Bring my parallels back in. Go ahead and deburr these edges on the part. So I would just grab my flat file, spot that it's going to remain for the rest of the machining operations. Now, I'm going to go ahead and snug it down, and then I'm going to move the table out of the way. I want to make sure that that's good and seated down. So a couple of smacks with the dead blow. Make sure that my parallels are nice and tight. Okay. So from this point on, I'm going to go ahead and square it up, and then I'm going to grab my edge finder and really figure out where I'm at on this part. So I could go ahead and do that now if I want to. Edge find off of this finished edge, and then these edges will stay the same. They'll already be finished on that part. So back to my spindle on. Bring this thing up to it. So I've got about 40 thousandths to take off of this edge. Again, I want to make sure that my x-axis and my y-axis are also pretty snugged on this. At this point, I'm going to go ahead and zero my digital readout, stop my spindle, grab my 2 to 3 micrometer, see where I'm at. So I have 25 thousandths left to take off of that. So, start my spindle back up. I'm going to take that in 2 passes. I'm going to take a 15 and a 10. Because we're cutting aluminum with this part, I could easily have just taken that all in one shot, but just to make sure that everything's going nice and smooth, you might be actually working on a steel piece on your part. This is just the piece that I had and grabbed today. So yeah, I've got 10 thousandths left to go. Take that in one pass, going across it. So my digital readout now says negative 25 thousandths. Alright, so at this point I'm going to go ahead and stop my spindle, hit the brake, and then for my x-axis, this is a 3/4 end mill, so I could really go ahead and set myself. I can adjust it to set. I can hit my X at 0.375 and already have that pretty close to where I want to be. I'm going to go ahead and use my edge finder here in a moment. But one of the things I need to do is kind of look at my part and see best way to attack this thing. I'm going to run it like this. So here is my 0 point. So as of right now, here is my 0 point. Now if I want to flip it around, I can do that at this point. I can make the part look as it says for print. Then this corner down here, or I'm sorry, this corner up here becomes my 0 point. That's my datum. And so let me just move some of this stuff out of the way. So on this, I would want to go ahead and take a look at where I'm at on my part and kind of see what I want to make this part do. Do I want to try and run it with 0 here? If I do, that's fine. It probably makes more sense to work off of the print like that, even though I did just set X here, or roughly set X here. It's not going to change anything. I can go ahead. I've got to bring in my edge finder anyways to get this Y-axis so I can hit both the X and the Y at the same time. Make this corner X0 and Y0. Then, if I want to, I can kind of figure out exactly what it is that my part is going to look like, at least kind of roughly shape of this part. Now, one of the ways that you can do that is just to lay it out with some Dicom. Today, I am just going to take and just kind of roughly mark out with the scale where my part is going to be sitting at. So 1 inch, 1.5 inches. I got a couple steps there. I've got a large diameter that's going to go all the way through my part here. This is a small tapped hole. This is a ringed hole. I've got a slot. It's going to go right down through here. And I've got 2 1/8 inch holes there. So if I want to look at my side view, I've got something that goes down like that, and then like this. Got a couple of steps. Obviously, not to scale. All I've done was just kind of give myself an idea of what this part should look like. So I've got something visual to work off of. That just helps me kind of figure out what's going on. So now, if I want to, I can go ahead and I can either edge find it, or since with my 3/4 inch end mill, I'm just going to be ripping across full length here. I might just bypass that. Go ahead and start making some cuts. My first cut looks like it's going to be down. So I'm 200,000 step right here. So I go from 900 to 700. So I've got 200,000s on that step. I can either take all of my material off of this side, all of my material off the other side. Doesn't really matter. We are on parallel, so the bottom part should be flat. So I've got a kind of a visual of what my part should look like. I'm going to go ahead and take 100,000s off the top of this part and then start ripping out these 2 steps. Okay. Now, normally I would fly cut this. I've already got this tool in here. And in just an effort to kind of maximize some time, since I don't know how long I'm actually going to be able to be in the shop today. So here I just barely touched on the part. Stuff out of the way. While I'm here, I'm going to go ahead and set my dial on my knee. So I'm just bottom cutting, so it really doesn't matter which way I go. Go ahead and go up 50. stop my spindle. Clean top of my part off, make sure I got enough clearance area there. So 947. Now, tolerance on this part, 3 place decimals plus minus 5. I'm going to go ahead and take off the other 47 thousandths in one clean shot. So I'll give it a little bit more RPM. Zeroed my knee so that I can go ahead and make my next steps. I'm going to get my spindle stopped, check that thing for height, still got my 0 to 1 out, make sure that I'm 900. I am 902. I'm going to call it good there, well within tolerance. So I'm going to come around and start ripping some steps. So my first step I'm going to take, and it's going to be leaving this large 1-inch area. So this area right here, I want to leave it alone. So I'm going to come in, and I got my scale again, and I'm going to take and grab it at the 1-inch mark. So I want to make sure that I stay away from that. I'm going to go down 200 thousandths on that step when I finish anyways. Okay. I can go ahead and go on up to 100. I should be able to go ahead and go on up to 150. Bring my RPM down just a little bit. Rough down that other step as I was going and started to kind of step up. So one of the dangers in doing this, I'm only going off of my marker, which is okay for this, but I would generally tell you it's better to go ahead and know where you are on want to do is I want to measure that step out. So I'm going for here to here at 1 inch. Already got my micrometer out, and 0 to 1, oh, not going to work. Well, I know that I'm over 1 inch, so I can either grab my 1 to 2, or I do have my calipers out. Go ahead and measure that. So I'm 145 thousandths away. So at this point, I'll go ahead and set my digital readout, 145. Start my spindle back up. And so I'm just going to go ahead and take off some more until I get closer and bring the thing in. So go down to 100, just to kind of keep some things even. Now you'll notice I'm side cutting exclusively right here, so I want to make sure that I'm conventional cutting. Okay, I'll bring it down within about 15. When I get closer to finished size, I'm starting to kind of slow my feed rate down. Now, we don't have power feed on y-axis, so just a hand feed on that. Okay, start my spindle. Oh, don't do that. Okay, I should be able to go ahead and use my micrometer at this point. It should just be just a little bit over. So without deburring it, I'm at 17. So I'm going to go ahead and just grab a file and quickly go over that in just to make sure I'm not hitting on anything. Let's do one quick double check. Yeah, still 17. So we'll go ahead and start to spindle back up. Take one more pass. And on this pass, we will take it to about -2. Kick the RPM up just a little bit. That dimension should be in tolerance now. So we'll go ahead and stop our spindle. Okay, there we are. 1 inch, 1/1000th, plenty tight for tolerance. And let's see. So now we can go ahead and let's see. I don't have a depth mic out here, but I think I might be able to stretch across there. Unlock my table a little bit, move it out of the way. See if I can stretch over enough just to double check my depth on that. Yeah. Alright, so it looks like I'm still a little bit oversized on that step. So I got about 7 thousandths more to go for that step. So I'm going to jump back in there and take just a little bit more off the bottom. And so when I do that, I don't really want to come across that wall if I don't have to. So I'm going to come up. Go back to I'll stop at -1. I'm going to come up just a little bit with my tape. That dimension should be 700 thousandths now. 702. Well within tolerance, or at least within tolerance. Call it good for today. Our next step, we need to bring in our 500. This step is going to be 1 inch wide. So just to kind of keep some eyeballing going on here, it's going to be about to here. Okay, so something like that, and it is going to be 500 thousandths. So not as deep of a step as we had originally made. Something about right there. Go ahead and color that in. Try to. This is our mark that we're going to just come in and rough that out. I really like to have a visual. Go ahead and bring our RPM down a little bit. So I need to come down about another 200 thousandths. So I'm already at 0. So I'm going to go ahead and take this in a 100 thousandth shot. Give myself a visual just to make sure that looks right. Tighten my X and my Y down some just to give it some snug. Now I'm going mostly bottom cutting. Created a little bit of a help for me in this part as when I used my digital readout, I brought this in and brought this at 0. So this step from here to here is a 1/2 of an inch. So on my digital readout, when I read approximately 1/2 of an inch, I should be there for that next step. Okay, so I'm already stopped. I'm going to double check just with the scale dimension my overall height, and it looks like I am about at 600. So I'm going to give it another 80 thousandths, 90 thousandths. I'll go ahead and go up this step, or across this face, I should say. Now, go ahead and step over. So my digital readout reads 5, let's go 530. Come up this step. Now from this point, I'm going to go ahead and grab my 1 to 2. So this step from datum point should be about 1.5 inches, or should be 1.5 inches exactly when we're done. At this point we are 1 inch 526 thousandths. So we're just off a couple thousandths on the digital readout. And so what I could do is I can go ahead and, if I want to try and get to that number exactly, I can go ahead and change this to 1 inch 520, what did we say? 527. So 1 inch 527, enter. The point is essentially now set over to this edge. Start my spindle back up. Go ahead and bring it in 2 passes. So I'm at 510. Give myself a little more RPM. Okay, 510. So at this point, I want to go ahead and bring depth in. I'm going to bring it back over here. Go ahead and bring it over to 1 inch 500 on my digital. And then go ahead and bring up my last 10 thousandths on my step. Up in. Finish out this edge and the bottom at the same time. And now I'm going to come over here, knock out the rest of this floor. Alright, so at this point, I've got, actually let's go this way so you can see it a little bit better. Okay, got my part squared up. I've got my steps put in. So far I've stayed within the same tool as well. Now, not having you guys here, as some of you guys have already noticed from creation of my CNC video the other day, is there's none of you to rip on or give a hard time to. And so I can only imagine as you sit and watch this video, some of you guys are ready to go, intently watching, ready to tell me every move that I've done wrong. And just know that I've put those wrong moves intentionally in the video just to keep you on your toes. So then for others who will remain nameless, you guys are completely crashed out, sitting at your desk, computer, wherever, in front of a gaming console, or you sped through the video and didn't watch any of it at all. And so wake up, pay attention, see what's going on. I tell you guys all the time, you'll make great machinists because you are great at nitpicking and finding details, and I like to make fun of you about that, but I think that those are also really good qualities. You want to pay attention to some detail. Now on this part, I can deburr most of it with the files that I have here. Some of these edges really probably need just a little bit smaller files for this. This will work once it's out of the vise. I might be able to do just a little bit better job of deburring it. But as of right now, I'm about 35 minutes into it. 35 minutes to get myself overall length set up, and then mill down all the steps in the overall height. So we're right about on time. We're just trying to get this part done in a reasonable amount of time. Having to stop and explain some things takes just a little bit longer, but not too bad. So now we kind of need to figure out what it is that we want to do next. We need to kind of just be thinking a little bit methodical about the way that we run this part. For me, I'm probably going to go ahead and get all of my milling steps taken care of, all in the same shot as I can. I cannot use this 3/4 inch end mill to get this 350 slot taken out. So that's just not going to work. So another thing that I probably want to go ahead and do now, just so I can get this slot placed in a good spot, is to, I could go ahead and run my edge finder now if I want to. That would be probably a smart move to do. So at least I can find the center of where this thing is. Because what I want to do is I want to take my 5/16 end mill. Already got a 5/16 end mill already set up. Take a 5/16 end mill right through the center slot of this thing. So we'll go right through the middle. And then we'll do some quick math, figure out what our step overs are going to be for this. So my next move, I think, is going to be that I will go for my 5/16 end mill. All right. So this is one of our older mills. This is the mill that John Kincaid usually uses, which I'm not sure why, because John, you're pretty short, and the other mills are just a little bit better. And honestly, the only reason that I chose this one, pure selfish reasons today, the vise was still attached, and if you notice all the other machines in the shop, the vices have already been removed, because that's how they're supposed to be. So I'm not knocking you, John, because I know you would have not left it like this, but let's just say you are now failing. So I've got a 3/8 shank on this 5/16 end mill. Let's just see what we have in here. If we're lucky, we get a edge finder. No, so we have an edge finder, but it's 1/2 inch. So we'll need to flip back, grab a 1/2 inch R8 collet, pull this guy back out. Throw our 1/2 inch up in there. Alright, so tight enough in there. I am going to, let me pull some of this stuff out of the way. Try to keep a little bit of organization here. So I'm going to make this my 0 point. So it's going to go right to that corner. It's going to be my X0, Y0. Okay, so we can start a spindle up. Loosen our table locks. Now I hope that you guys are all doing well at home, that you're getting a little bit of extra time maybe with the kids or with your wife or husband, your spouse, your friend, your dog, whatever it might happen to be. This is definitely no fun to be hanging out here by myself. So I went ahead and hit my digital readout, we can set it to 100. I did not watch for the kickoff, so I'm going to go back over here. I got myself talking and wasn't paying attention. So I'm going to come over here. Oh, there's my kick. And reset that at 100. Okay. Now, I'm going to go ahead and move my quill up, straighten my edge finder up, just because that annoys me. And did not I did not hit set or enter on my x-axis readout, so I need to redo this. Kick and enter, and now just duplicate those things. Now I can move over another 100, double check that with the visual, and then flip my digital readout to 0, hit 0. So that x-axis is done. So now, come over here to my y-axis, get a wobble on again, bring it down, come up, or come close to the edge, wait for it to stop kind of wobbling, and then watch for the kick. There we go. And so that's my Y, and I can set, I just had set, or 0 set on my digital readout, so I'm going to come down 100 thousandths. I don't know how you guys feel about online machining. I know from our side of things we have fought like crazy just to get you guys back in the shop, but until we get some type of sign or okay, which I don't see that happening anytime super soon, just to kind of give you a heads up and not to get too distracted in what I'm saying, but so I don't think that you guys will be back and really until summer, but I do think summer probably shows some pretty good hope. Now, to kind of give you guys the other side of things, we got 3D printers running. Right now we are printing on the Mark Forge some masks just in case we need them, and a couple of different reasons why we may need those. There might be a possibility that we can get you guys back maybe in small groups, and if we're using masks. At this point we really don't know. This is really uncharted territory for all of us. But it is definitely more difficult just to kind of do everything without you guys here. I'm going to go ahead and bring my quill all the way back up, lock it down. My part is 1 inch wide. So I'm going to come over here and I'm going to go to the edge of this part. So I just noticed that my part is not 1 inch wide. So I'm going to need to, when I'm done here, I'm going to need to come in and take out this last step. I did not pay attention to that. So, and the only reason I noticed that is because this center part here is 475. So this works fine. I'll go ahead and work off of this edge, bring this in 475. When I'm done, I'll flip it over on its side. Not a perfect scenario, but it'll still be okay. So 475 is the center of my slot, and I'm going to go ahead and bring my y-axis down 475. Should have been paying attention a little bit better as I was going through there, and went ahead and squared that edge up. So in that case, I would have taken my fly cutter and hit both of those sides at that time. That would have been a smarter way to run that part, or to run this part. Okay, so quill is up and such a small windmill, I could easily bring my quill down. I really just like to run my quill up as high as I can. I like to run it up there tight, and yes, it's just a little bit of extra work, but I really feel like having that spindle up there nice and tight does a good job. Alright, so I'm just barely touching there. I'll zero out. Now that slot goes down 200 or 200 thousandths as well. So we can go ahead and go on down 100. Go one full revolution. You know, one of the things I think I'm going to do before I do that, I think I'm going to go ahead and mark out my 300 thousandths on each side. So it's a little tight. So I'm going to mark out 300 thousandths, and then the slot is 350 thousandths wide. Something like that. It's not centered because my part is still 1 inch wide. It needs to be 950 wide. That is a disappointment that I did not notice that. So I'll go ahead and lock my table down. Now I'm just slotting through here, almost all bottom cutting. Okay. Go ahead and bring myself up 10 thousandths from the bottom of the slot. Now, what I can do, if I want to, I know that I'm already there, and I want to try and match that up the very best that I can. So there I'm right at 200, got my slot made nice and smooth. So this is just coming into the middle of the part. Okay. You cannot even really feel that step on there. I'm going to grab my calipers and just measure this step over here. So this would be the 300 thousandth step on the far side. I'm 320 thousandths. So, back with my spindle. So if I do the math on that, pull up my Machinist Calc Pro app, got it clear. That should be 300 thousandths plus half my end mill. And if I don't know that, I can go to 0.3125 divided by 2, 1 inch 5 or 105.62 thousandths, 156 thousandths. Plus 300 thousandths would be 456. I am at 476, so I'm about 20 thousandths off. So that's pretty close. So I'm going to go to 466. working up this edge, okay? So I am about 6 thousandths away. So I'm going to move another 6 thousandths. So I'm at 466 now. $460. On the dot. Okay, so now I need to get the other side of that slot, and so 300, 650, that means that slot's going to be 350 thousandths wide. Now, I cannot really work off of this. I can, I just need to add 50 thousandths to it. So that would be 350 plus 350, so 350 for the slot, 350 on this side, and then 300 thousandths on this side. So I can definitely do it like that. Really what counts is the width of this slot. What I need to do is grab some 350 thousandths gauge blocks, or a 350 thousandths gauge block. So instead of 350 thousandths gauge block, I found some gauge pins. So gauge pins will do the same thing. I'm going to go ahead and grab a 350 thousandths wide gauge pin. I'm going to use it as my final gauge, but when I get closer, I'm going to go ahead and grab a couple of different ones. So this other side, which we already did the math on, we know it should be 350. It's 365 right now. So I'm going to come in and just do a real quick cleanup on it. One thing I'm going to do with it, what I don't normally do, is I am going to climb cut that side. So I'm at 460 on the y-axis, so clear 460. I need to make that slot 350. So I'm already, let's see, I've got my width of my end mill, which is 0.350 minus 0.3125. So I need to move 37 thousandths. I'm already at 460 plus 0.037. So it should be about 497. My finish is going to be at on that. So what I want to do is I'm going to come in here and I just want to barely touch the edge of this slot. So I know 497 is where I really should finish at. So I'm going to go to 487, and that'll just tell me if my math is right. Now here's one thing I'm going to do on this, is I'm going to just bring it in just really shortly, just barely into the radius of that mark, and then I'm going to go ahead and check with my gauge pin, just to make sure that gauge pin does not go in, just to make sure I don't oversize that slot. So I'm good to go. Okay, I'm going to climb cut. Now, my end mill is super small, so I really don't have to worry about anything big happening. I'm not taking a big cut either, but I really just don't have room to move much on this other side without really kind of changing what the bottom of that step looks like over there. Almost tempted to go across the entire bottom of that step with that 5/16, just so we can kind of keep that same look at the bottom of that end mill. So I am 360 right now, so I'm 10 away. So I'm going to go to 497, and here's one thing I'm going to do is I'm not going to take off any tension off of my axis lock, so I'm going to go ahead and just leave them alone. I'm going to try to spin the spindle the right direction now. Okay, so climb cut up this side. That should finish on my slot, bring me to 350. And again, I've got 3 place decimals on that, so I've got 5 thousandths that I can play with on there. Hopefully, I will be pretty darn close to where I need to be. That pin fits in there perfectly, so I'm going to say that we are at 350 for our slot. So I'm going to put my pin over here so that I don't lose it, and I make sure that it gets put away. You guys may not be familiar with that, putting things away. So that takes care of my shape of my part. All I have left now to do is holes. Kind of attack holes a couple of different ways. I can go big to small, I can go small to big, I can go drilled holes, then reamed holes, then tapped holes. It's kind of dealer's choice on something like this. So I'm going to go ahead and loosen up my axes. Get my 5/16 end mill out of there with my 3/8 collet. I don't have anything else to use my 3/8 collet for, so I can go ahead and grab that thing and get it out of there. One thing that I noticed that I did not bring out was a center drill. So typically on those 1/8 inch holes, I would probably go ahead and center drill them. A lot of times I tell you if the surface has already been machined, it's already nice and flat, you get away with not doing that. So let's just try that today. I'll go ahead and grab my 1/8 inch drill. We'll go ahead and put these 2 holes in here. We'll see what it looks like if we can get away with not center drilling that. I think the center drill always looks good. You're going to want to chamfer it, deburr it at some point anyways. I think it always just looks nice to do that chamfer, spot drill, center drill first anyways, just to keep it looking good. Remember, if you can't make it right, make it shine. I've done that a lot today. Okay. So should still have my edge finding location should still be good. So I'm going to go over in X 500 thousandths. As I get close, I'm going to go ahead and start snugging down my axis locks. So about right there. Then I need to come down 150 and Y. Okay. Go ahead and lock that one. Moved just a little bit, not bad though. So here I can do a couple of different things. I can use my quill, and I can kind of set a gauge there. I can move this up. You may have never even used this before. This is the quill stop. A couple of different styles of quill stops that you can have or use, and I might have one of mine out, a spring-loaded one that hasn't disappeared. Let me see if I can grab it. Must be on loan, so I can go all the way up here. I can use my quill stop to bring this thing up here. This is a little time consuming to get this in here, so I can do that. I can bring that all the way up there. That will create a stop as this moves down. I can do that. There's a spring-loaded one that I have that just hooks on here. What I'm going to do is I'm going to go ahead and bring my bottom of my line here to 0. Okay, you gotta watch out because that nut right there is right in the way. So I'm in position, and so I'm gonna go ahead and put my spindle on and bring my table up to where it just hits it. My depth on that needs to be 500 thousandths. Bring it to where it just barely goes in. And so my quill is now unlocked. That looks like it started nice and straight. So I'm going to go in a little bit, clean the chips out, maybe go in 50 thousandths or so. One thing I didn't do is I should have probably marked those holes before I started drilling, just to make sure that my location matched up. I'm just beyond 1/4 of an inch. I'm about 5/16. Up on 1/2 of an inch. Okay. Okay. So there, I am ready to go. to my next hole. Next hole from location is 800 thousandths. So I will just loosen my Y, leave my X alone, go to keeping some positive direction going on there, go down to 800 thousandths. The exact same thing, 500 feet. Got to start getting on the hustle here because typically my camera has a tendency to shut off after 2 hours. So we are an hour and 7 in. Alright, so I am not going to check the depth of those right now. I feel pretty confident about where they're at. But before I take it out of the vise, I will check those. What I don't want to do is end up with a couple of holes that are just a little bit short. I am going to go ahead and check those for location just to verify that they're good. 500 there, 150 from the edge, and then 800 to the edge, or to the center, sorry. Okay, so I've got those 2 holes knocked out. Now it's time to change. I'm just going to go from left to right, I guess. So I'm going to go ahead and do that tap tool next. Probably should have brought a little tapping oil over here with me, but I didn't. Making long, in-depth videos of me manually machining is not typically what I'm doing. So, forget some steps along the way. Alright, so I'm going to go ahead and bring over both of these collets. I've got a collet set up with my 3/8 tap, and I've got a collet set up for my 5/16 drill. So 5/16 drill, this print already shows you what it should be as far as diameter wise, which is awesome. And so it does give a max depth for diameter, and I would say the reason why they are concerned about that is because the idea is that they do not want you to go through the bottom of this part. I don't want you to go through the bottom of this part either. And I don't want me to go through the bottom of this part. So, it says 0.55 max full diameter. So that means we have to actually drill deeper than 550 thousandths. But, how deep is that? Is the question, I guess. Let's see, what is the middle of that? 475. So for what? And it's going to be 1 inch, 250 thousandths. Now, if you'll notice, I'm always getting the slack out of the table. This is 0, so I'm always trying to go positive. Pressure, no slop in my movement in that direction. So 250, okay? And go ahead and really give a snug down on both X and Y. All right, so go back to my calculator. Now you all know my password, all my top secret information. So I am 0.312 times 0.3 equals 93 thousandths plus 0.550 deep. 0.093 plus 0.55. Nope. 0.093 plus 0.55. 643. Okay. So what we need to do is I'm going to do something real similar to what I just did. I'm going to go ahead and set my quill down to 0. I'm going to turn my spindle on, bring this all the way down. Barely going to touch there. I'm going to go 643 deep. So how deep is that? So here is 1 inch, here is a half of an inch, here is 3/4 of an inch. If you look at these, 100, 200, 300, 400, 500. So 643, we're going to go 500, 600, and about halfway through there. Okay, spindle's on, quill is ready to be unlocked. About 500 deep right now. Go ahead and take this and clean off the chips on there. Now, if you'll notice, I have not really had to change RPM very much. And ever since I went from my 3/4 end mill, because I use a 5/16 end mill, and now I'm at a 5/16 drill. I did kick it up just a little bit for my 1/8 inch end mill, but not really much at all. 500, 600, okay. Okay. So, be careful when you do this. Actually, don't do this. This will be my safety lesson for don't do that. Do as I say, not as I do, I guess. Okay, so we're already in position. We might as well go ahead and chamfer that and tap that. I think what I'm going to do is probably go ahead and do my hand chamfering on all of that because I'm pretty tight to the shoulder. Not sure that I can quite get in there with my tool to put my 82-degree spot, or yeah, my 82-degree spot there. Take a look at it and see if I've got enough room to do that. Another thing we have to think about in tapping this hole, it's a blind hole. We want to be really careful in tapping that thing. We need to know how far down we can go, get full thread. Keep in mind, probably your last thread or so will need to be maybe. I'm going to save that one for hand drill to use. Okay, so we're going to tap 420 thousandths deep. Okay. So I'm going to mark out where a 1/2 inch is at the bottom of this tap. Okay, so right there is where my 1/2 inch mark. If I hit that, that means that I'm at the bottom of that thing. I can always have more threads, but I can't have less threads. At least on a part like this. Okay. Now I've chosen to use the collet instead of the drill chuck because the drill chuck keys are junk. Alright, we'll grab a little bit of cool tool. would have thought about it today, I would have worn a red shirt for Team Red Shirt, but I didn't. I just happened to have this one on and went with it. So I'm gonna go ahead and kick down into low gear, and hopefully that'll be close enough. It's not bad. Now I'm gonna go down with my tab. Hold tab. Okay. That went pretty smooth. So leave that alone. Move over to my last hole operation. Then I'll have to flip it over, knock off 50 thousandths off that one side because I was foolish in the beginning and did not pay attention good enough. I'm gonna kick it back up into high so I can move it around just a little bit easier. So my last operation for this is going to be drilling and reaming. The large 3/4 hole. So, some of you guys may have already sent me some information for a Facebook login. All that is for is I know that you guys love to communicate, talk to each other, and ask and answer questions, even if they're not related to the class that we're in, and that's fine. By doing that, it's a closed group. It's not going to be people from all over the world are not going to be joining in, just be us. It's all of our machinist students, just to be a way for us to communicate just a little bit better since we're not able to see each other in class. All right, so this is a, I believe, 47/64 drill. Let's double check. 47 divided by 64 is 734 and some change, so it's about 15 thousandths under the 750 hole that we're going to put in there. Okay, so probably go back to that low side. It's probably a little slow for that. Super slow for that. So this hole goes through. If you use the quill stop by moving this up here, kind of its only drawback is the fact that it's now all the way up there. And I've watched a lot of guys drill holes, and they hit that quill stop, and they don't realize that they're on it, and they will they'll be pushing like crazy and not going anywhere. So we'll go ahead and drill on through this. Okay, did a battery change for one camera. One camera is on the low side. All right, so I'm gonna go ahead and just gonna, let's see, zero my readout out. And I'm gonna move over because I need to come back and need to ream this hole. Try and get this thing wrapped up here in just a few moments. Kick back up to the hot side just so I can move it around a little bit better. One thing that I noticed about myself as I'm doing this is I used to work in the shop a lot, and I never ever wore a ring or a watch. And when I started here, I dropped that habit and started wearing a ring and a watch. So I noticed myself, even just today, wearing my watch and my ring, and that is not okay. So I just noticed it a second ago. Go ahead and tighten up this reamer. side. Move my table way down so I can ream that hole. I'm gonna hope that it doesn't hit that other parallel. It's gonna be really close. So end with an up stroke. I'm gonna go past the hole, back to it. So both of those should be at 0 or really darn close. Okay. 0. Okay. Now, let's see. Can do a little bit of a speed change. For my reamer. Remember, speed and feed for the reamer are different than they are for the drill. Ream on through there. Okay. That hole is reamed. Okay, so the only thing that I have left to do, and it's pretty smooth, it doesn't look like it from there, but it's pretty smooth. I'm gonna go ahead and take this part out. Everything else has been done to it. Everything else, all the other chamfers I'll take care of with the cordless. So what I'm gonna do at this point, I'm gonna need to do a quick debird for it. At least everywhere that's important, so I can flip it over on its side and knock out the rest of it. And if the air compressor was on, I would give it a quick shot of air, clean it up. Alright, the rest of that's pretty good. So, foolishness on that, not milling that thing to size, made me want to stop the video and restart. So then it worked out perfectly and everything was awesome. Now if you look in there, my threads are not very deep. I'll hand tap those the rest of the way. Just didn't want to have tab bottom out and cause me any kind of problem there. So this is, it's not the best part in the world, but it's acceptable. If you'll notice the slot that we put in there, any type of mismatch that we had, our hole covered it up. So that worked out pretty darn good. So now all I have to do is make this 1-inch part 950. Now my problem is it's no longer nice and square. When it was square, it's much easier to do, right? What in the world am I doing making this